we are going to talk about second thing you are learning in this class. Okay, it's called log function. And for log function, you are going to learn. And before we do that, we need to talk about more operations of the functions. Okay, so just like the basic skills you have learned, it's all about add, subtract, multiply, and divide, and simplify sometimes, right? For all the fractions, polynomials, rational expressions, right? Okay, so for functions, besides add, subtract, multiply, and divide, you also learn another two operations. One is called composite, one is the inverse. Okay, and for functions, then we need to see what kind of composite functions are, how do they operate, and what kind of inverse functions they are before we can learn log functions. Okay, so let's review the notations always. So we say if y equals 3x minus 1, y equals x squared minus 2x, right? That's linear, that's quadratic. Then we say and x is 2, what is your y? Then for us, we need to differentiate them, right? Both are functions. So we say this is f function of from x to y. Then we'll call this g of x. Okay. Then that's the notation we have been using, right? That's how we differentiate them. Then you can say, okay, f of 2, you use this, g of 2, you use this, right? So that's your notations. And for poly, then we did what? Add, subtract, multiply, and divide, and simplify, right? So for function, same thing, we do this. Then plus we are going to learn composite function, and we are going to do inverse functions. Two more operations. Let's talk about how functions add, subtract, multiply, and divide, right? Let's see. So if I have f, is this one, and let's make an easy one. Okay, so show you the operation first. So for function f, from x to y, that's your y, right? That's your y. So f is saying whatever you give to me, your y will give you 3 times back, right? Then for g function is saying whatever your x given, your y will be minus 2. Okay, so that's the y. Then let's learn how to add, subtract, multiply, divide the functions, right? So what do you think? Fx plus g of x, right? What do you think? You just add them. So if we do f plus g for the x, That means you are going to add f of x plus g of x, right? Then for this one, what do you think? That would be 3x plus, that would be 4x minus 2, right? Then if you want to minus two functions, so what do? You just do f of x minus g of x. So that would be this minus that would be what? 2x plus 2, right? 3x minus x, okay, so that's plus 2 then. Then if you multiply them, what do you think? If f times g, what do we need to do? For the x, what do you think? You just multiply them, right? So you multiply them becomes 3x squared minus 6x, right? What do you think? Division would be, that would be your f of x divided by g of x. That would be, becomes a rational function. Becomes a rational function, right? And for the new operations you are going to learn, okay, let's do composite function first. So, what does composite mean? You compose, right? Just like a music, you compose, you add one tune to another, right? So for the functions, to compose them, that means you stack up, right? It's like if f is from x to y, is the function get from a to b, point x to point y. If g is from y to z, right? Then what is composite function means if you compose them together, then you will get what? From x to z, right? So if I have this one, same thing. If I have f of x equals 3x, g of x equals x minus 2. All right. So if I do this way, let me move this away. So f of x equals 3x. Okay, I can just write f of x equals 3x, g of x equals x minus 2, right? So if you have 1, then for x, then you get 3 times, right? f relates from x to y by 3 times of it, right? So that would be 3. Then if it's 100, that would be 300, right? Let's do the 10 first, then 100 will be 300. So if you go through the g from here to here, it will minus 2. It relates the input to output by minus 2, right? That would be 1. That would be what? 29 or minus 2. That would be 298, right? That means if you stack up f first, then to the g, you compose them. So if it's 1, then you end up with what? 1, right? Minus 2, yes. Then 10 become 28, right? 100 becomes what? 298. Is that right? However, if we do same number, if I do from x to y to z, right? So if I do g first is x minus 2, then I do f. I stack up differently, okay? So that will be what? X, 3x, okay? I probably don't do 1 because 1 minus 2 become negative. Okay, let's just start from here. So become 10 to where? Minus 2 would be 8, right? If it's 100 and minus 2 would be 98. Okay, I can do 1. That's negative. Okay, if 3 times, then stack up into f, then would be what? Negative 3. Here would be what? 24. Here would be what? 294. Is that right? Okay, so when you have 1, 2, 3, 2. Okay, so when you have same thing, you put it into the, for the x, 1, 10, and 100. 1, 10, and 100. If you stack up to f first, then g, or you stack up g first to f, do you get the same results? You don't. Okay, so I just want you to see it first, to see some numbers. Then we write the notations for it. Okay, so notations are this way. For stacking up, for composite functions, we do it this way. So when we stack up, we use this symbol, F, we call Cheerio, right? A little circle, that's a formal symbol of the function. So what does that mean? If I stack up for x, whatever closest to x first, you will do that first. So for this one, we do f Cheerio g, right? X means what? I will do g of x first, okay? Then I stack up to f. If I do g Cheerio f of x, it means what? Which one I will do first? I will do f first. F of x, then whatever you have, you stack up to here. So you look at these two situations, right? This one, which one we do it first? F first, then G. F first, then G. So this is this case, right? And this one, if I do F Cheerio G, means what? I do G first. I will do this way. Okay? That's called composite function. Right? That's the symbols you are learning. So we are learning the composite things right now. Okay? New operations for you. So let's take a look how we are going to do some examples. Okay, so take a look here. Okay, right? We are on the page 26, section 10.1, right? So that's C. Oops. I cannot concentrate today for some reason. Sorry. Okay. Let's focus. right? So let's do F trivial G of 3. So for this operation, what do we need to do? What kind of result? That means what? For 3.3, then go through G, right? Then go through F. Where do you get? Right? So, let's see. So first, you just follow this. All right? So we do G first. So you change the symbol like this. So you can plug in. Okay? So G of X first, 3 times 4 plus 1 is 13, right? So then you plug in 13 to here, you get a 502. If we have G trivial F and 3, what do we need to do? Which one we should do first? F, right? So you plug in F to here, you got the 22. Then you plug into G, you get 89. Do we have same numbers? Not really, okay? So a lot of time they are different, but sometimes they are the same. So if we do this way, if we ask you F trivial G of X, what do we want you to do? It means it's X, right? Then you will answer the question with X. You will have a little bit issues with this for some reason, but you can manage. So G of X is what? Is this guy, right? You'll be fine here. However, next step, you will have some issues. F is saying, whatever you give to me, I will square you, right? Then multiply by 3 and minus 5. So now your X is no longer X, it's 4X plus 1 in place of X. So it means what? You need to put this in X place, like here, right? And take the square and minus 5. That's what you need to do. When you stack up, X is no longer X here. It becomes what? 4X plus 1. It's like a 4Y plus 1. You plug in, you'll be fine. But when you use the same symbol, X, 4X plus 1 in X, at X place, you mingle them, right? You will mess up. So you multiply them out and simplify it. So you should give the answer like this. Okay? You can multiply them. If we say G trivial Fx, what do we need to do? We need to do f of x first, right? Then you know f of x is this guy, 3x squared minus 5, right? Now we are going to put this into G place, this guy into G place. Then G says, whatever you give to me, I'm going to relate you there times 4 times plus 1. So whatever is given for G, right? G says it will multiply 4 times plus 1. All right, so what do we have? We have 12x squared minus 19, right? So we just introduced the composite function. okay, how to compose functions together. When you stack on top of each other, you put in one at a time to the next one. But look at that. In general, okay, so in general, your F cheerio G, when you compose them, and the G cheerio F, okay, are they the same? They are different in general. Okay, so we just introduced the first operation for the function called composite function, right? Now, let's do the next one, inverse function. Let's see how we are going to operate them. Okay, let's do next operation. It's called inverse functions. Okay, what does inverse mean? Inverse means what? If you go from A to B, you reverse what you did. So you go back from B to A. So you go back to original position. So if you go X to Y, then you go back with the Y to X. Okay? So the function, what is a function? We have to inverse the functions, right? So what are functions? A function is what? Formally we say, we keep repeating this, right? It's a set of what? Ordered pairs and x, y, right? Just because they always go together from point A to point B. Then you go back, ordered pairs, right? So such that, remember for functions, each x value, you can only have what is paired with what? Exactly one y value. Right? We keep repeating this, so make sure you remember. Okay? Then, before we talk about inverse function, we need to talk about something called one-to-one function. Okay? So, we said if I have one pound of nuts cost me $3, then 2 pounds of nuts I still sell $3. Is this a function? Because for each x, you only have one y value, right? I can sell all same price, not a problem. So it is a function. However, if so, do you think it's one-to-one function? Not really. You can tell it's not one-to-one. It's 2-to-1, right? So what is one-to-one function? One-to-one function means what? Each y value, okay, will match with, okay, exactly one x value. Because to be one-to-one, you have to have 1-to-1, not a 2-to-1. Right? They are different things. Okay. Why we wanted to talk about this? we are reviewing what is a function first again. Then we are talking about one-to-one function for the purpose to learn the inverse function. Okay, so let's identify this first before we talk about inverse function. If my f is 3, 6, -5, -2, 5, 1, 6, is this a function? Function? Yes. Is this one-to-one? No. Right? It's not one-to-one, two-to-one. So if g is this way, if -1, 6, 3, 8, 2, 7, -1, -4. Okay? Is this a function? No, because -1, one value, one x value, you have two matched y value. You cannot do that, right? So this is not a function. So we don't talk about one-to-one function. Okay? And next one, if I have this one, 4 to 4/5 and 3 to 3/5 and 2 to 2/5, right? Is this a function? Right? 1x, not the two y values. Is this a one-to-one function? It is. Okay, so we talk about what are functions, what are one-to-one functions, okay, for the purpose to figure out the inverse function. So let's take a look more graphing. Okay, so is this a function by graphing? You use a vertical line test, right? So is this a function? Yes. Is this one-to-one function? One-to-one is what? Like here, I have say 2, 1, I might have -2, 1, right? -2 to y is 1. Is this a one-to-one function? I have 2 and -2 mapped to 1. 2 to 1. So it's not 1-to-1. So it's not 1-to-1. Right? So if you look this way, if this one like this, is this a function? Yes. Is this 1-to-1? For each x, you only have one y, right? No repeated. So this, yes. Okay, how do we decide if it's a one-to-one function? For function, we use a vertical line test, right? For one-to-one function, we use something called horizontal line test. So you do this way. So you see it meets two places or one. So if two places, that means not a one-to-one function. So this one is not, this one is. Right? If you look at the sideways parabola, is this a function? Vertical line test? No. So then we don't talk about one-to-one function. Okay? So you can see from the graphs, okay? So unable for us to do one-to-one function, okay? So for one-to-one function, So you have to satisfy vertical line test and horizontal line test, right? So if I want to reverse back, okay, so first we learn the one-to-one function. Then for the inverse function, we want to reverse back. Okay, we write this notation F inverse. It means it has to be one-to-one to be able to do the inverse. Okay, because from X to Y, from this point, right? If you have this one function, -2 and 1 and 2 to 1. If you do inverse, will be 1, -2, right? When you inverse means what? You reverse X and Y. You reverse the X and Y, right? Also, if I reverse X and Y, -2, 1 become 1, -2, 2, 1 become what? 1, 2. Okay? Then if I reverse them, if I have this thing, do I have a function? This is a reverse. It is not, right? When you reverse, one X value can only have what? Can only have one Y value. If you have two things mapped to one number, or you reverse, one number will map to two numbers. Then that will not be function, right? So for the inverse function, F inverse, right? It has to be what? 1-to-1. Okay? The inverse of F, we write it this way. This one has to be 1-to-1 to have inverse. Then same thing, F inverse will be 1-to-1. So for every xy point belong to xy, then its inverse will be yx. That will belong to the inverse function. That's the symbols we are going to use for your inverse function. Okay? So first, we get idea about what kind of things are inverse. Inverse means what? You're going backwards, right? From x, y function paired, ordered pairs, right? For those x, y belongs to F, its inverse will be what? Yx. You reverse your x and y's. Okay? So, oh, I just erased earlier. Then, earlier we have this, right? H equals, say, 4 4/5, then 3 3/5, and 2 2/5, right? So let's take a look. Is this a function? Yes. Is this 1-to-1? Yes. Okay, then what's your inverse? Reverse x and y's. So your inverse function would be this way. 4/5 maps to 4, 3/5 to 3, 2/5 to 2. That's its inverse, right? And next one if you have f equals this, negative 1, 3, 4, 6, and 7, 3. Okay, is this a function? Two numbers mapped to 1 is fine, right? But the one number can only map to one number, not two numbers. So it is a function. Is this 1 to 1? No. Right? So you don't have the inverse. Okay? So if you have next one, 1 to 2, 7 to 8, negative 3 to 6, and 7 to 9. Is this a function? 7 maps to two numbers. So this is not a function. Okay? Then we don't talk about one-to-one function. All right. So let's look at the page 28. Here says the fact. Okay? If a one-to-one function is given, all right, as a list of ordered pairs, how do we find its inverse? To find the inverse, it means what? We will switching the x and y coordinates in each ordered pair. Okay, so it means what? You switch x, y to y, x. All right. So if it's ordered pairs, all you need to do is what? You switch x, y to y, x. Right? However, sometimes it's not that obvious. So if you write the function f of x is linear function, right? How you are going to find its inverse? It should be a function style like this. So it's not ordered pairs. If it's ordered pairs, you can do it right away, right? If you have a situation like this, it's more complicated. Okay? But for graphing, you might be able to do it. Okay? So let's take a look. If you have this way, okay, let's look at the B first. All right, let's just look at the graph. Okay, so if original graph looks like this, here is a negative 2, 0. Cannot see the point. Here is 0 and 1. Okay, another point is, this is so tiny, 2 and 3. It's right here. So if you have 2, 3, and another point is right there, is what? I cannot see it. Okay, so that would be negative 3 and negative 3. So that would be negative 3 and negative 3. So it goes like this. It goes here and goes here. Right? Then, is this a function? Is this one-to-one function? Horizontal test. Yes, it is. So it should have inverse, right? If it's ordered pairs, you can just reverse them. And if it's a graph, how can you find the inverse? You should show it as a graph. So what do? You use the points, right? So -2, 0 would be what? 0, -2. 0 is here. 0, -2. So that one will match to this one. 0, 1 would be what? 1, 0. Right? 2, 3 would be what? 3, 2. -3 would be -3. But it's opposite of that. So how does it look like? So opposite would be like here, right? Go through this point, go through this point, go through here, okay? Then go there, opposite. Okay, so when you do a reverse of the graph for 1-to-1 function, so -3 still -3, 0 still 0, 1, 1 still 1, 1, and -1, -1, -2, -2, right? So you will go, all those points will be there, the same x and y. So if 3, 3, 2, 2, 1, 1, when they do opposite, still same. So this is the line you will reflect to. Okay, so what happens is, if this part would be this part, right? Then for this part, that would be this part, right? So second quarter would be fourth quarter, okay? 1 quarter, first quarter, still the same. Just like you will, okay, fold, if it's a square thing, then you will just fold diagonally, okay, to map your inverse points. Got the idea? That's how you graph the inverse function of the graph. Okay? So functions can be shown in ordered pairs or with graphs, right? Then ordered pairs, you just inverse. Then graph, then you just find the points, then reflect over the y equals x lines, right? So, however, what happens if you have a function look like this? Okay, if you have function look like f of x equals 3x plus 3. Is this a function? It's a line. Y equals mx plus b, right? Then how do you find the inverse function? Okay, so if you look at the graph, then you would do this way, right? First, you graph it. So 0 would be what? 1, 2, 3. 0, 3, right? Y-intercept. Then rise over run, it's 3 over 1. So 1, 2, 3, 3 over 1. This point, that would be what? 1, 6. Right? Or you can come down here. So come down 3 over 1. So this point would be what? -1 and 0. Right? And if I count down 3, 1, 3, one more time, I will have here, that would be what? -2, -3, right? So my line looks like here, okay? Look like this one, right? Then how do I do the inverse? We can just do as a graph, right? So its inverse would be what? You find the point. 0, 3 would be what? 3, 0, right? -1 would be what? -1, 0 would be 0 and -1, right? Then 1, 6 would be 6, 1. And -2, -3 would be what? -3 and -2. That would be here. -3, -2. Right? So your inverse will be this line. Is that right? Okay. It will reflect over the y equals x. Okay. However, let's take a look. Because original one is what? A function, right? Right in the formula. Then you have to answer this one similar way, not just graph. You have to find the function way. So this is a line, right? Then what is this equation for? So what's your y-intercept? So y equals mx plus b, right? So your b is what? Actually is -1, right? And what is your slope for this inverse line? So rise over run, right? Like this one, rise 3 times, run over 1. But for your inverse will be what? Rise 1, run over 3. So your inverse line, the slope of the inverse line actually is what? 1/3. Right? So your equation, your linear equation will be that one. So how do you show the answer? It's inverse. So you write the inverse notation, okay? For the x is what? 1/3 x minus 1. So that would be your answer for the inverse function for that. Okay? But like this one, you can see your y-intercept. You can write it, then you can count your slope. But sometimes it's not that obvious, then you won't be able to do this way. So what we need to do is algebraically doing that. So how should we do? Look at your page 28. The steps is on the top. Okay? So it's called switch and solve. Let's see how we would do that. Okay? Because originally is this one, that's your x and y. When you do the inverse, you wanted to do the y-x. Okay? So follow the step. Let's see. First, it says replace f of x with y. Okay? So you do y equals 3x plus 3. Right? The method is called switch and solve. Then, second step is you have to switch your x and y. So it becomes what? X equals 3y plus 3, right? Then switch, then solve. We have to solve y by itself because we are going to write y equals some x as a function, f of x, right? You have to get a y by itself. So what do? We solve it. So x minus 3 equals 3y. Then what's your y? You divide it by 3, right? So what do we have? Y equals 1/3 x minus 1. X over 3, 1/3 x. Is that right? Then that's still not good enough. The question was find the inverse. You have to write it in inverse notation. Okay? So you have to do f inverse of x equals this one, 1/3 x minus 1. So that will be your final answer. Okay, so are they the same? So this called what? This is called switch and solve. Okay, that's how we do. But how do you know you are doing right? Like this one, you can see it. We verified it by the graph. Okay, but if we actually doing it for more complicated situation, we need to check. Okay? How do we check? It means from x to y, if you're going back, you should go back to x. Right? That means if I have f of x to the y, if I go back, this is my f. Going this way, going back is f inverse, right? So my x to the y, then if I go back to the f inverse way, that's y, then you go back, you should get back to x, right? Then same way, if I go inverse way first, y, so y, I go inverse way, I do x. Then if I go f way, I should get back to y. Is that right? Okay, but instead of doing x and y, because when we do the problem, originally we only have x, we don't use y here anymore. We just use the original, use the x to check. Okay, so for checking, we need to satisfy these two conditions. It would be difficult for you to do this, to check on this. And if you have a problem with it, you can just skip it. You can still get your ABC, your grade, but you have to do everything else correctly, right? But for your pre-cal and calculus, you need to learn this to check. Okay, so we said this one, f of x equals 3x plus 3, its inverse would be what? We just find the inverse of f of x should be what? 1/3 of x minus 1, right? So how we are going to check? We're not going to emphasize the checking for this class, but for some of you, you might be interested if you want to go further. Okay? So let's do those. So we are on your page 29 on the top. Okay? Let's see how we are going to check it. See, when we do the oops. So, when we do the inverse, okay, we need to use the composite functions to check it. Those are composite functions, right? Because you compose going there and coming back. Have to get back to original. So we have two things to check when you check. So first thing, if you check F inverse F of X, see if you can get it to X. How do you do? We say you need to do F of X first, right? So that's F inverse. What's your F of X? 3X plus 3, right? Then how do you do the inverse one? Inverse saying, if you give me X, I will do the, whatever you give to me, I will do what? The multiplied by 1/3 and minus 1. Right? 1/3 of X minus 1. But now your X is this one, so you will do that by plugging. So 1/3 is X plus 1 minus 1, right? X plus 1 minus 1, so you get X. So you get back. That's how you check. Okay, then see if we can check F trivial F inverse X. Okay, it means composite function. Then you do F inverse X first. F inverse is what? Is this guy, right? 1/3 X minus 1. Then you do F. Then F is saying, whatever you give to me, I will 3 times you and plus 3, right? So whatever is given, right, you will multiply by 3, then plus 3. That's what F said. Okay, then it's given this, so you put in here. Okay, then you multiply, that's X. It becomes what? X minus 3 plus 3, then you get X, you get back. That's how you check. Okay? If you get confused with those, you can just skip it. Okay? You need these concepts for the pre-cal and the calculus. You don't need this for business calculus. Okay? All right. Of course, for your homework and for your exams, we will have one of those problems. But the problem may be 6 points, checking maybe just 2 points. Okay? If you get confused, you can let it go. So we are here on your page 29. Then do some more of the inverse function. Okay? Let's find out if your inverse function is this one. Okay? Or you can write half of X minus 7/2. Either way, they are the same. Okay? So this is a linear function similar to this one, right? So the method is called what? Switch and solve. So first step, you write y equals 2x plus 7, right? Second step, switch x equals what? 2y and 7. Third step, solve it, get y by itself, right? So 2y equals x minus 7, then divided by 2. So your y is what? Half x minus 7 halves, right? If you leave there, then you will get a 1 point deduction, right? Because what was the question? Find the inverse. You have to show where is your inverse. With proper notation, that would be this guy, right? Would be half of x minus halves. Okay? Let's go through the checking again. For some of you might need it, right? So checking is you have to check two things. F inverse, that's F inverse x equals x, right? Another one is what? F inverse x equals x. You have to satisfy these two conditions. So first one, let's do that. So F inverse fx, you do which one first? F of x first, right? So f of x is this one. So that's 2x plus 7. Then you put into F inverse. Then F inverse is saying whatever you give to me, right? I will have it and minus 7 halves. So it's 7 is saying whatever you give to me, right? I will have it, right? And minus 7 halves, right? According to this. So that's F inverse. So you put this back here, x plus 7, then you check. That's x. So x plus 7 halves minus 7 halves. What do you have? You got x. Right? So you get back. How about check this one? F interior f(x) inverse x. So you would do F inverse x first, right? So what is your F inverse x? It's half of x minus 7 half, right? Then it says, F says, whatever you give to me, I will trace it n plus 7. So F says, whatever you give to me, I will trace it, right? Trace whatever you give to me, then plus 7. Right? So that's your half of x minus 7 halves. Then cancel out would be x minus 7 plus 7. So did you get back? Yes, you do. Right? Okay. So that's what we need to check is these two conditions. All right. So for linear equation, linear functions, right? We did it twice. So you got some idea. Okay? If you have this one, g of x equals x cubed minus 3, then what's your G inverse? That was the question, right? So we say the method is what? Switch and solve. So first, that's your Y, right? Then switch. Right in Y, then you switch. X equals Y cubed and minus 3. And solve is what? Get Y by itself, right? So you add a 3. So switch and solve. Okay, we switched. So you have what? X plus 3 equals Y cubed. Solve means what? Get Y by itself, right? So get Y by itself, you have to take cube root, right? Get Y by itself. But that's not good enough. That's Y equals cube root of X plus 3, okay? But we say the answer has to be written in what? Inverse style. So that's your inverse. Answer the question, find the inverse. Oops, not F. See? It's G. Okay? So it's what? Cube root of X plus 3. So that will be your answer. Right? But to check, we say, what do we need to do? We need to find what? First, like this, right? Get back to itself. G inverse, real Gx need to be X, and G real G negative X need to be X. We need to check those. Okay? So, first, let's do this one. So, what do we have? G negative inverse G of X, right? So, you will do G of X first. That's this one. X cubed minus 3, then put step into G inverse. G inverse is this one. It says G inverse is saying what? Whatever you give to me, right? I will add 3, then take a cube root. G inverse is saying whatever you give to me, right? I will add 3, then take a cube root. Is that what this one is saying? Okay? So now the given one is x cubed minus 3. So that's the one it's given. Right? So what do we have? Those cancel. So you have cube root of x cubed. That's x. So you get back. Okay? Then for this one, let's see, G inverse of X, you will do inverse first. That's this guy, right? Inverse of X would be X plus 3. Then you put into G. Then what does G say? G says, if you give to me X, right? I will cube it, and whatever you give to me, I will cube it and minus 3. Is that right? So whatever is there, then that's the thing given, then cube it, right? And minus 3. So this one cube it will be x plus 3 minus 3, then cancel out. So you get back where you started. That's how you prove it. Okay? It takes a long time to do the proving. And if it's too complicated for you, as I said, you can skip it. It's not critical if you don't have to use it later on. Okay? So that will be our section 10.1. Two more operations for functions. One is composite function, one is inverse function. Make sure you do homework, otherwise you won't be able to do the test. Are we good?